What we doing?
So you have to measure out 0.125.
What we doing?
So you need to get 0.125 grams of that salty stuff.
The salty stuff. All right.
We started off this lab by creating a 0.02 molarity copper sulfate pentahydrate solution. We did this by putting 0.125 grams of copper sulfate in our little beaker and mixing it with water.
Oh. Bag acquired. Bag acquired. Here.
We added aqueous ammonia to our solution to get rid of the insoluble compound copper oxide. You can see this change by the dark blue complex ion that was formed after the aqueous ammonia was added. To finish our stock solution, we added water up to the 25 milliliter line in the flask. We then made our first dilution by putting 5 milliliters of stock solution into the flask with water. This made calculating the molarity of our first dilution really easy because we knew it was 1/5 the molarity of the stock solution. We then made our second dilution by using the same process, but instead of using 5 milliliters of stock solution, we used 5 milliliters of dilution 1. We then filled cuvettes with all the solutions we made, water, and the unknown solution, and headed to the spectrophotometer. We went to the spectrophotometer because it measures absorbance by shining light through it. We planned to find the absorbance for our knowns first and create a graph from Beer-Lambert law. Then we would find the absorbance for the unknown and see where it fell on the graph to find the unknown molarity. When using the spectrophotometer, make sure to wipe down two sides of the cuvette so that the light can shine all the way through, and to close the lid. We plugged all the data from the solutions that we made into Excel to make this fancy chart. We then took all the data from our unknown and found the average absorbance and plugged it into our chart to find the unknown molarity.